At 05:20 on the morning of February 2nd, 1945, Master Sergeant Clyde Whitmore climbed into the commander's hatch of a vehicle that the United States Army Ordnance Department had never designed, never approved, never manufactured, and never, in the 4 months since it had first rolled out of a Belgian farmyard repair depot smelling of welding smoke and improvisation, officially acknowledged as a weapon of war. He was 34 years old, former iron worker from Pittsburgh, Pennsylvania. 14 months of combat across North Africa, Sicily, and Western Europe. A man who had spent his adult life understanding what metal could do when forced into shapes it had not been built for, and what happened to men inside metal when that metal failed them. The vehicle underneath him had started its life as a standard M4A3 Sherman medium tank. It had ceased being a standard anything on the night of October 14, 1944, when Whitmore and 3 members of his maintenance crew had spent 11 hours in a Belgian farmyard with cutting torches, welding equipment, a flatbed truck carrying salvaged components from 4 destroyed vehicles, and a disagreement with the laws of military procurement that Whitmore had decided to resolve through metallurgy rather than paperwork. What they had built was not, by any conventional definition of the word, a tank. It was not, by any conventional definition, anything else either. The hull was Sherman, original M4A3 lower hull, drivetrain intact, suspension modified with wider track assemblies salvaged from a destroyed M4A1 that had been sitting in a ditch outside Liège for 3 weeks. The turret was not Sherman. It was a modified combination of the Sherman's original 75mm gun housing, a 37mm gun from a destroyed M8 Greyhound armored car bolted to the turret's left side behind a fabricated armored shield, and a 60mm mortar tube mounted in a fixed forward-facing position through a hole that Whitmore had cut himself in the turret's forward face using a cutting torch and 45 minutes of concentrated work that his crew watched from a respectful distance. 3 guns, 1 vehicle, no manual entry, no ordnance catalog number, no armor protection rating for the added components, no ballistic calculation for how the mortar's recoil would affect the turret ring under sustained fire. The men of the 2nd Armored Division's Maintenance Battalion had called it different things during the 4 months since its construction. Some called it the patchwork. Some called it Old Ugly. One lieutenant from Alabama, who had seen it for the first time on a foggy morning outside Aachen, had stepped back from it with the expression of a man confronting something that violated his fundamental understanding of how vehicles should look, and had said, with the specific eloquence of a man who needed only one word, Frankenstein. The name had stuck. The Siegfried Line was 800 meters ahead of Whitmore's position, the line that Hitler had called his West Wall, the fortification network that German engineers had spent years building across 390 miles of Germany's western border. Concrete bunkers, steel-reinforced pillboxes, interlocking fields of fire, anti-tank obstacles called dragon's teeth that jutted from the frozen Belgian earth in rows that stretched further than a man could see from ground level. The conventional military assessment of the Siegfried Line was that it could only be breached through sustained artillery preparation, coordinated infantry assault, and armored support that accepted significant vehicle losses in exchange for terrain. The conventional military assessment had been correct for every unit that had attempted to breach it in the preceding 4 months. Whitmore had read the assessment. He had also read the casualty lists. He had a different idea about what sustained artillery preparation could look like when it was attached to tracks and could move. Clyde Whitmore grew up in Pittsburgh during the years when Pittsburgh was the center of the industrial universe. Not metaphorically, not in the way that cities describe themselves when they are looking for a favorable comparison. in the literal, measurable, globally documented sense that the steel mills of the Monongahela Valley produced more structural steel per square mile than any comparable area on Earth, and that the men who worked those mills developed, over generations of contact with hot metal and mechanical force, a specific relationship with material science that no engineering school had yet found a way to teach in a classroom. Whitmore's father worked the blast furnaces at Carnegie Steel's Homestead Works from 1909 until 1941, when the Army took his son and the war took the last of the old ways of doing things. Whitmore himself had started in the Iron Workers Union at 18, working structural steel on the buildings that Pittsburgh's industrial wealth was putting up in the 1920s and 1930s at a rate that made the city feel like a place that intended to keep growing forever. He learned to read metal. This is not a metaphor. The men who work structural steel develop the ability to assess a material's condition, its stress history, its likely failure points, by sight and touch and the specific sounds it makes under load. A beam that looks intact can be read, by a man who knows how, as a beam that is carrying stress in the wrong direction. A weld that appears solid can be read as a weld that has been made too fast in metal that was too cold. The reading is not mystical. It is the accumulated pattern recognition of 10,000 hours of contact with a material that does not lie about its condition if you know how to ask the right questions. Whitmore brought this to the Army, and the Army, after a brief and unsuccessful attempt to assign him to an infantry training program in Georgia, recognized it and assigned him to armor maintenance. He was good at it in the specific way that men who have spent their lives understanding metal are good at anything involving metal. He could diagnose a tank's mechanical condition faster than any other sergeant in his battalion. He could improvise repairs that kept vehicles running past the point where the technical manual said they should be deadlined. He could look at a destroyed vehicle and tell you, within a reasonable margin, what had killed it and what might have prevented it. What killed Sherman's, Whitmore had concluded by the autumn of 1944, was not primarily German gunnery, although German gunnery was lethal enough. What killed Sherman's in the specific tactical situations he had been observing since North Africa was the combination of the tank's medium-range effectiveness and its complete inability to engage fortified positions at close range without exposing itself to the anti-tank weapons that defended those positions. A Sherman carrying a 75mm gun could destroy a German Panzer IV at 600 yards. It could not reliably destroy a concrete pillbox at 50 yards because the 75mm round, designed for armor penetration, did not produce the kind of broad concussive effect that a fortified position required. The round went through the pillbox's firing aperture if the aim was perfect, which at 50 yards under fire it sometimes was, but it went through the wall more often, punching a hole that killed no one inside and produced no structural damage that mattered. The infantry needed something that could suppress a pillbox at close range while they moved up to it. The artillery that could destroy the pillbox was too far back to provide direct support once the infantry was inside 200 yards of the German line. The gap between artillery range and infantry assault distance was the gap in which men died. Whitmore had been thinking about this gap since Tunisia. He had filled 2 notebooks with observations about what weapons worked at what ranges in what tactical situations. He had drawn diagrams. He had made calculations that were rougher than an engineer's and more practically grounded than a theorist's. By October of 1944, sitting in a Belgian farmyard with 4 destroyed vehicles around him and a maintenance crew that had nothing to do because the assault on the Siegfried Line had stalled and nobody was breaking anything new while they waited for the next attempt, he had arrived at an idea that he understood was either correct or catastrophically wrong, with no comfortable middle ground between the 2 possibilities. He picked up a cutting torch and found out which one it was. The night of October 14th, 1944, was cold and overcast and smelled of the specific combination of diesel exhaust and burned metal that had become, for every man in every armored maintenance unit in the European theater, simply the smell of work. Whitmore had 4 vehicles available to him. An M4A3 Sherman that had taken a track hit from a mine and been towed to the depot with its drivetrain intact but its right suspension destroyed beyond field repair. An M8 Greyhound armored car that had been hit by a Panzerfaust in its engine compartment and was mechanically dead but structurally sound from the turret forward. An M4A1 Sherman that had burned after an ammunition fire and was useless as a vehicle, but whose wider T-54 track assemblies and suspension bogies were intact. And a half-track personnel carrier that had been abandoned by its crew during a retreat and recovered by Whitmore's team, whose value to him was primarily the welding gas cylinders and cutting equipment still strapped to its rear cargo rack. He also had 3 members of his maintenance crew who had signed on to the project with varying degrees of enthusiasm and a consistent level of professional competence. Corporal Vasquez from San Antonio, who had worked automotive body fabrication before the draft and whose welding was the cleanest in the battalion. Private First Class Okafor from Detroit, who had grown up in a family that repaired heavy equipment and who understood stress loads on modified structures in the practical way that comes from watching what happens when a repair fails. And Private Dunning from rural Minnesota, who was 19 years old and had been assigned to Whitmore's crew 3 weeks earlier, and who had no specific applicable skills, but who was strong, willing, and had demonstrated the specific quality of following instructions precisely without asking questions that slowed the work down. Whitmore had explained what he intended to do before they started. He told them it was unauthorized. He told them that if the resulting vehicle destroyed itself or killed its crew, the fault was his, and he would say so in any subsequent investigation. He told them that if it worked, the fault was also his, and he would say so in the same investigation with different emphasis. He told them they could leave, and he would not record it, would not remember it, would not think worse of them for it. None of them left. They worked through the night. The Sherman's turret came off first, lifted by the depot's salvage crane, and set aside while Whitmore and Vasquez cut the mortar mounting aperture through the turret's forward face. The hole was 8 inches in diameter. It took 45 minutes. The mortar tube, a 60mm M2 salvaged from an infantry weapons platoon's destroyed equipment, was fitted into the aperture and welded in place with reinforcing collars on both faces of the turret wall. Fixed forward firing, no traverse. The mortar would fire in whatever direction the turret faced, which meant it would fire in whatever direction the tank faced. This was a limitation that Whitmore had thought about and accepted. A mortar that traversed independently would require a crew member dedicated to its operation, and the Sherman's turret was already crowded with the loader and gunner for the main 75mm gun. A fixed mortar that was fired by the commander from a simple electrical trigger added a weapon to the vehicle without adding a crew position. The commander aimed it by turning the tank. The 37mm gun from the Greyhound's turret was more complex. Whitmore needed it to have independent traverse because its role was different from the mortar's. The mortar was for suppression, for putting high explosive rounds into fortified positions and the ground around them to keep German soldiers' heads down while the infantry closed. The 37mm was for the apertures, for the specific problem of a pillbox slot that a 75mm round was too large to thread and an infantry rifle was too small to damage. Vasquez fabricated the mounting bracket over 4 hours. It was the most technically demanding fabrication of the night. The bracket had to allow 30 degrees of traverse while carrying a weapon that weighed 240 pounds under the G-forces of cross-country movement and the vibration of the main gun firing. It attached to the left side of the turret through a modified section of the Greyhound's original turret ring, which provided the bearing surface the traverse required. When they were finished, as dawn was beginning to lighten the overcast Belgian sky, Whitmore walked around the vehicle once. He looked at it from every angle. He looked at the welds. He looked at the traverse mechanism on the 37mm mount. He looked at the mortar tube protruding from the turret's forward face like an accusatory finger. He told Vasquez that the welds were good. Vasquez said they were the best welds he had ever made. He said this without pride and without modesty, as a statement of fact about his own work that the quality of the work supported. Whitmore nodded. He climbed into the commander's hatch. He looked at the 3 guns arranged around him, each one commanding a different range band, each one designed to address a different element of the tactical problem that had been killing men since Tunisia. He said that they would find out if it worked. To understand what Whitmore was about to attempt, you have to understand what the Siegfried Line actually was. Not the name, not the propaganda, the physical reality of it, as experienced by the men who had been ordered to breach it since September of 1944, and who had been paying for every meter of progress in blood that the casualty lists recorded with the bureaucratic precision of an institution that counted everything and felt nothing. The Siegfried Line, which the Germans called the West Wall, had been constructed between 1936 and 1940 under the supervision of Fritz Todt, the engineer who had also built the Autobahn and who brought to military fortification the same combination of industrial scale and practical precision that had characterized his highway work. The line ran 390 miles, from Clèves in the north to the Swiss border in the south. At its peak construction, 500,000 German workers had been employed on it simultaneously. The result was not a single continuous wall. It was a defense in depth, a layered system of mutually supporting positions designed so that no attacking force could destroy one position without exposing itself to fire from the adjacent ones. The bunkers were reinforced concrete with walls between 1 and 3 meters thick. The firing apertures were positioned to cover the approaches at angles that made direct fire suppression from the front nearly impossible. An attacker who approached a pillbox frontally was in the field of fire of the pillboxes on its flanks. An attacker who tried to flank it came into the field of fire of the pillbox ahead. The Dragon's Teeth anti-tank obstacles were pyramidal concrete structures between 90 centimeters and 1.5 meters tall, arranged in rows of 4 to 5, staggered to prevent any tank from finding a path between them without turning sideways and presenting its thinner side armor. They were reinforced with steel rods. A Sherman could not crush them. A Sherman attempting to drive over them risked bellying out, becoming high-centered with its tracks off the ground, immobile, a stationary target for every anti-tank weapon within range. The approach to any breach point in the Dragon's Teeth was swept by pre-registered mortar and artillery fire from positions that the Germans had been ranging and marking since the line was built. The engineers who designed the line had calculated, with the thoroughness of men who assumed it would eventually be used, the exact range and bearing to every natural approach point from every fire position in the defensive network. Any vehicle that stopped to deal with the obstacles was stopping on ground that had been pre-registered for fire. Allied attempts to breach the line since September of 1944 had followed a consistent pattern. Artillery preparation, sometimes lasting days, to suppress the defenders and damage the concrete where possible. Infantry assault to move through or around the obstacles with Bangalore torpedoes and demolition charges. Armor support that attempted to move through gaps created by the infantry, taking losses from the anti-tank weapons that the artillery preparation had failed to destroy because they were inside concrete that 155mm shells had damaged but not penetrated. The pattern produced gains measured in hundreds of meters per day, at costs that divisional commanders reported upward with the careful neutrality of men who understood that the numbers required no editorializing. Whitmore had read the divisional after-action reports in the maintenance depot, where they arrived along with requests for vehicle replacements. He read them with the specific eye of a man who was looking not for heroism or failure, but for the mechanical description of what had stopped the advance at each point. The pattern, he found, was consistent. The advance stopped when tanks were immobilized at the obstacle line, when infantry could not suppress the pillboxes long enough to demolish them, when the gap between what artillery could reach and what the assault needed filled with men who had no weapon suited to the task in front of them. 3 weapons at 3 range bands, that was what the gap required. Something for 300 meters to begin suppression while the assault was still organizing. Something for 100 meters to thread the firing apertures and silence the guns inside. Something for 50 meters to put explosive force into the concrete and the ground around it, while the demolition teams moved up. A 75mm main gun, a 37mm secondary, a 60mm mortar. 1 vehicle, 1 crew, 1 commander who understood what the gap was made of and had decided to fill it. The Frankenstein Sherman did not go straight to the Siegfried Line after its construction. It went first to the attention of every officer in the 2nd Armored Division's chain of command who became aware of its existence, which produced a response that was less uniformly enthusiastic than Whitmore had hoped and more bureaucratically complicated than he had expected. The first officer to see it on the morning of October 15th was the Maintenance Battalion's executive officer, a captain named Holloway from Virginia, who had spent his career working within established systems and who looked at the Frankenstein Sherman with the expression of a man who has been presented with something that will require him to make a decision he would prefer not to make. Holloway asked Whitmore what it was. Whitmore told him. He explained the tactical concept. He explained the range band analysis. He explained the specific problem of the gap between artillery support range and infantry assault distance, and how 3 weapons at 3 range bands addressed it. He was precise and he was calm, and he spoke for 8 minutes without notes, because the argument was in his head in the same way that a complex structural calculation lives in the head of an iron worker who has been doing the same class of calculation for 16 years. Holloway listened. Then he told Whitmore that the vehicle was unauthorized, that the modifications had been made without ordnance approval, that the structural integrity of the turret ring modifications was uncertified, and that the vehicle could not be operated until it had been inspected and either approved or condemned by the division's ordnance officer. Whitmore said he understood. The ordnance officer, a major named Frescott from Ohio, arrived the following morning. He was a graduate of the Ohio State University engineering program and had the specific skepticism of a formally trained engineer confronting a field-fabricated solution to a problem that his training suggested should be addressed through proper channels. He walked around a vehicle for 20 minutes. He examined Vasquez's welds with the close attention of a man who understood what he was looking at. He operated the 37mm traverse mechanism through its full range of motion. He asked Whitmore 3 technical questions about the mortar mounting collar's weld pattern and the stress calculations behind it. Whitmore answered the first 2 questions correctly. The third he answered approximately correctly, using the ironworker's understanding of stress loads rather than the engineer's notation, but arriving at a number that Frescott later confirmed was within 12% of the formal calculation. Frescott said the vehicle was unauthorized. He also said the welds were better than most factory work he had inspected. He said this in the specific tone of a man who is noting a fact that he did not expect to note and is being honest about it despite its inconvenience to his overall position.
He filed an inspection report that described the modifications in technical detail, noted the fabrication quality, identified 3 structural concerns requiring remediation, and recommended that the vehicle not be operated in combat until the concerns were addressed. Whitmore addressed the 3 concerns over the following week. Frescott re-inspected. He filed a second report that cleared the vehicle for limited operational evaluation. The limited operational evaluation lasted 3 weeks. During those 3 weeks, Whitmore drove the Frankenstein Sherman over every terrain type available in the Belgian rear area, fired all 3 weapons at the division's improvised range, and produced a set of operational data that Frescott compiled into a third report that recommended the vehicle be considered for combat evaluation under controlled conditions with senior officer observation. The recommendation moved up the chain. The divisional commander, a major general who had the specific pragmatism of a man who had been fighting since North Africa and who measured everything against the question of whether it would keep his men alive, read Frescott's 3 reports and Whitmore's original range band analysis and the casualty figures from the previous month's Siegfried Line attempts. He approved combat evaluation. He also, in a conversation with his operations officer that was not recorded but was later described by 3 officers who were present, said that if the thing worked, he would personally write the letter that got Whitmore a field commission, and if it didn't work, he would personally write the letter that explained to Ordnance why his maintenance sergeant had spent government welding gas on a vehicle that looked like it had been assembled by a man who had lost an argument with a scrapyard. The combat evaluation was scheduled for February 2, 1945. The target was the Siegfried Line.
The assault on the Siegfried Line on February 2, 1945, was not designed around the Frankenstein Sherman. It was a divisional assault involving 2 infantry battalions, a standard Sherman company, artillery preparation, and engineer teams equipped with demolition charges for the Dragon's Teeth obstacles. The Frankenstein Sherman was attached to the assault's left flank element, with orders that Whitmore had negotiated personally with the battalion commander, a lieutenant colonel named Parrish, who had read the operational evaluation reports and who had, in Whitmore's assessment, the specific quality of a commander who was willing to let an unconventional asset operate unconventionally if the unconventional operation produced results. Parrish's orders were simple. The Frankenstein Sherman would operate 100 meters ahead of the standard Sherman company on the left flank, moving to the Dragon's Teeth line and using its weapons to suppress the pillboxes covering the obstacle gap that the engineers needed to reach and demolish. If the vehicle was destroyed before reaching the obstacle line, the standard company would continue the assault without it. If it reached the obstacle line and completed its suppression role, the engineers would move up and the assault would continue. Whitmore had 1 additional crew member for the operation. His regular driver, Corporal Tanner from Georgia, who had been driving Whitmore's maintenance vehicles for 8 months and who had agreed to drive the Frankenstein Sherman into combat with the specific, uncomplicated courage of a man who has decided that the driver of any vehicle goes where the vehicle goes, and that arguing about the destination is the commander's job, not his. At 05:20, with the pre-dawn darkness still complete and the temperature at 18 degrees Fahrenheit and the frozen Belgian ground hard enough that the tank's tracks rang against it with a metallic clarity that carried further than Whitmore wanted, he climbed into the commander's hatch and began his check. Main gun, 75 mm, 71 rounds loaded. Secondary gun, 37 mm, 94 rounds loaded. Mortar, 60 mm, 48 rounds racked in the turret. All 3 firing circuits tested and confirmed. At 05:40, the artillery preparation began. The sound of 105 mm and 155 mm guns firing from the division's rear positions was, to a man who had been in this war since North Africa, as familiar as weather. It was background. It was the machinery of the assault organizing itself in the pre-dawn dark. Whitmore listened to it the way a man listens to traffic noise in a city he has lived in too long to be surprised by, as information about the state of the environment, rather than a sound requiring attention. At 0560, the preparation lifted, shifted to deeper targets. The silence it left was not silence, but the comparative quiet of artillery fire having moved away, leaving the closer, smaller sounds of men and vehicles beginning to move. Whitmore told Tanner to go. The Frankenstein Sherman moved forward. The German defenders of the Siegfried Line's left sector had survived the artillery preparation in their concrete bunkers the way they had survived every previous artillery preparation, by going deep, closing the blast doors, and waiting with the patience of men who had learned that the bombardment always ended and that the men who came after it were the real problem, not the shells. They emerged from their positions at 0607, 4 minutes after the artillery lifted, and found the standard pattern of an Allied assault forming on the open ground 600 meters from their line. Infantry moving in dispersed order, taking advantage of the frozen ground's relative lack of cover. Standard Sherman tanks moving in support, staying back from the dragon's teeth at the range that experience had taught them was survivable. Engineers moving up in the wake of the infantry, carrying the Bangalore torpedoes and demolition charges that would deal with the obstacles when the infantry got close enough. They had seen this before. They knew how to respond to it. Pre-registered mortar fire on the infantry forming areas, anti-tank fire from the flanking positions on the Sherman Company at 600 meters, machine gun fire on the engineers as they approached the obstacles. The defense would inflict losses, the assault would stall, the losses would accumulate, the pattern would repeat until the Allied commanders accepted the cost, or the Allied reserves were sufficient to push through regardless. What they had not seen before was the vehicle on the left flank that was not behaving like a tank. It was moving faster than the Sherman Company, not dramatically faster, but noticeably, pushing forward at a pace that suggested it was not intending to stop at the range where standard Sherman doctrine said to stop. It was closing on the Dragon's Teeth line at an angle that would bring it to the obstacle gap that the engineers were targeting, and it was already inside the range band at which the pre-registered mortar fire would need to be adjusted. At 500 meters from the obstacle line, the Frankenstein Sherman opened fire. The mortar fired first. Whitmore had the turret faced toward the leftmost pillbox in the sector, the one whose field of fire covered the approach corridor that the engineers needed. The 60mm mortar round covered 500 meters in a high arc and landed 12 meters short of the pillbox. Whitmore called the correction to Tanner. Right 2, add 15, and Tanner adjusted the vehicle's heading, which adjusted the mortar's azimuth, and Whitmore fired again. The second round landed on the pillbox's roof. A 60mm mortar round landing on 2 meters of reinforced concrete produces negligible structural damage. This was not news to Whitmore. The mortar was not for structural damage. It was for the defenders inside, who were now experiencing the concussive effect of a high-explosive round detonating directly above their position, which was not lethal, but was disorienting in a way that disrupted aimed fire from the firing apertures for the 5 to 10 seconds after each impact. 5 to 10 seconds of disrupted fire, repeated every 15 to 20 seconds as Whitmore fed the mortar, was enough to make the approach corridor survivable. At 300 meters, the 37mm gun came into effective range. Whitmore shifted his attention to the firing apertures. The left pillbox's aperture was a horizontal slot 30 centimeters tall and 60 centimeters wide, positioned 1.2 meters above the pillbox floor to allow the machine gun inside to depress toward the approach. A 37mm round could pass through that slot. A 75mm round could not. Whitmore fired 4 rounds through the aperture over the next 90 seconds as Tanner continued the advance. The 4th round went in clean. The machine gun in the left pillbox stopped firing. At 150 meters, the Dragon's teeth were directly ahead. Tanner slowed. The engineers were moving up behind the vehicle, using it as cover. Whitmore traversed to the second pillbox, the one on the right, whose field of fire had been crossing with the left one and which was now without its partner's supporting fire. He put 3 mortar rounds onto its roof in succession. He put 2 37mm rounds through its aperture. He fired the 75mm gun once at a point 3 meters above the aperture, where his analysis of the construction suggested the thinnest section of wall was located. The 75mm round did not penetrate the concrete. It produced a crack pattern that spread 40 centimeters from the impact point and let enough of the blast pressure into the aperture space that the machine gun team inside ceased to be functional. The engineers reached the Dragon's teeth. The engineer team that reached the Dragon's teeth on the left flank at 0641 on February 2nd consisted of 9 men under the command of a first lieutenant named Brewer from Connecticut, who had been breaching obstacles since Normandy, and who operated with the methodical precision of a man for whom a concrete obstacle was an engineering problem with a known solution, and the only variable was how much time the solution required. Brewer's men carried M1A1 Bangalore torpedoes, metal tubes packed with explosive, designed to be pushed under wire obstacles and detonated to clear a path. They also carried demolition charges, 40 pounds of C2 explosive in waterproof packs, which were what they needed for the Dragon's teeth. The Dragon's teeth were the problem. Concrete pyramids 1.2 meters tall, reinforced with steel rods, set in a concrete base plate that extended 50 centimeters underground. A charge placed at the base of a single dragon's tooth and detonated would remove that obstacle. Removing 4 in a row, the minimum gap needed for a tank to pass through, required 4 charges, 4 detonations, and approximately 8 minutes of work in the open, within 200 meters of German positions that had not been fully suppressed. The Frankenstein Sherman made those 8 minutes survivable. Whitmore kept the mortar cycling on the pillboxes covering the approach while the engineers worked. When a German soldier appeared in a firing aperture, the 37mm gun addressed it. When a German mortar team opened fire from a position 400 meters behind the Dragon's Teeth line, a pre-registered position designed exactly for this moment, for the engineers who would inevitably reach the obstacle line if the assault got far enough, Whitmore turned the turret toward it, used the 75mm gun at 400 meters, and put 2 rounds within 15 meters of the mortar team's position, which was close enough to produce casualties and disrupt the firing. At 0649, Brewer's team placed the last charge. They moved back. Brewer detonated the sequence. 4 Dragon's Teeth ceased to exist as obstacles. The gap was 4.2 meters wide. A Sherman needed 3.6 meters to pass through. The arithmetic was favorable. Brewer signaled back to the standard Sherman company. The first Sherman moved up. What happened next was the validation of everything Whitmore had built the Frankenstein for, and the moment at which the tactical concept it embodied stopped being a maintenance sergeant's improvised argument and became something that had actually happened and therefore could not be argued away. The standard Sherman company moved through the gap. They encountered a second line of pillboxes 200 meters behind the Dragon's Teeth. Whitmore moved the Frankenstein forward with them, through the gap, and began suppressing the second line with the same 3-weapon approach he had used on the first. Mortar on the roofs, 37mm through the apertures, 75mm on the wall sections above the apertures when the angle was right. The second line took longer. The defenders were deeper and better protected and had had time to observe the approach and adapt their defensive fire to avoid the apertures. 3 German soldiers came out of a bunker's rear entrance and attempted to place a demolition charge under the Frankenstein's tracks.
Private Dunning, riding in the hull gunner's position with an M3 submachine gun through the hull gunner's port, shot 2 of them. The third retreated back into the bunker. Whitmore put a mortar round through the bunker's ventilation shaft. At 0847, the second pillbox line was suppressed sufficiently for the infantry to move through. The battalion's lead company moved 600 meters into the defensive zone before German counterattacks from the flanks required them to consolidate. They had been through the Siegfried Line. The left flank breach was the deepest penetration the 2nd Armored Division sector achieved that day. It was the only sector where the Dragon's Teeth had been cleared under fire without the engineers taking casualties. It was the only sector where the 2nd pillbox line had been suppressed without the Standard Sherman Company losing vehicles to aperture fire. Lieutenant Colonel Parrish filed his after-action report at 1800 hours. He described the Frankenstein Sherman's role with the specific precision of a combat commander who understands that what he is describing has implications beyond his own sector. He used the phrase layered suppression at multiple range bands. He did not use the word Frankenstein. He described the vehicle as a field-modified fire support tank with 3 primary weapon systems covering distinct engagement ranges. He recommended the modification for division-level evaluation.
Parrish's after-action report reached 1st Army Headquarters on February 6, 1945. It was accompanied by Frescott's 3 inspection reports, Whitmore's original range band analysis, and a personal endorsement from the divisional commander that described the February 2nd operation in terms that left no interpretive ambiguity about the writer's view of the modification's value. The Army Ordnance Department's response was not generated by a single officer making a single decision. It was generated by the accumulated weight of an institution that had spent years building the case for standardization as the foundation of industrial-scale warfare. Standardization meant that every Sherman in every theater used the same parts, that maintenance crews trained on one vehicle could work on any vehicle, that supply chains could be calculated in advance rather than improvised, that the chaos of combat did not extend into the supply systems that fed it. A field-modified Sherman with 3 non-standard weapon systems fabricated from salvaged components using field welding equipment was everything the standardization argument was built to prevent. Every spare part it needed was a part that the standard supply chain did not carry. Every maintenance procedure it required was a procedure that had no manual entry. Every crew member who operated it needed training that existed only in the mind of the man who had built it. These were real concerns. They were not manufactured. They reflected genuine operational experience with the consequences of fielding equipment that the supply system could not support. The Ordnance Department's formal response to Parrish's report acknowledged the February 2nd results, commended the tactical innovation demonstrated, and declined to authorize replication of the modification on the grounds of standardization, supply chain integrity, and uncertified structural modifications that posed a crew safety risk that could not be assessed without full engineering review. The response also noted, in a section that its authors may not have intended as ironic, but that read as such to every officer who received it, that the problem of fire support in the gap between artillery range and infantry assault distance was a known tactical requirement that the Ordnance Department was actively addressing through the development of the M4A3E8 Sherman with the 76mm gun and improved fire support capabilities. The M4A3E8 had 1 gun. Whitmore read the response in the maintenance depot outside Cologne in late February. He read it twice. Then he filed it in the same folder as the casualty lists from the previous month's Siegfried Line attempts and went back to work. He did not build another Frankenstein Sherman. He had made his argument. The argument had worked once, in one sector, on one morning, and it had worked well enough that 11 men who would otherwise have been engineers lying in the frozen ground in front of the Dragon's Teeth were instead soldiers who had gone through the Siegfried Line and were continuing to move east. Whether the institution chose to hear the argument was not his to control. He was a maintenance sergeant. His job was metal. He picked up the cutting torch. The Frankenstein Sherman survived the February 2nd assault undamaged except for a cracked road wheel on the left suspension that Okafor replaced in 40 minutes at the assembly area behind the breach. It was used in 3 subsequent operations in February and March of 1945, each time attached to a flank element of a larger assault, each time producing results that were documented in after-action reports that moved up the chain of command and accumulated in files that the Army Ordnance Department had created specifically for field modification assessments. The vehicle was finally destroyed on March 19, 1945, when a German 88mm anti-tank round struck the right hull behind the driver's position. Tanner was wounded but survived. The rest of the crew was unhurt. The vehicle was not recoverable. The turret and its 3 weapon systems burned with the hull. Whitmore stood outside the fire and watched his work disappear. He did not rebuild it. The war in Europe had less than 2 months left by then, and the supply of destroyed German positions requiring layered suppression at multiple range bands was diminishing rapidly as the Allied advance pushed east. He returned to maintenance work. He repaired the vehicles that came back broken and sent them forward again. He filled out the reports that the Army required. He did not file any further proposals regarding multi-weapon fire support vehicles. But the argument did not disappear with the vehicle. The after-action reports that Parrish had filed and that the divisional commander had endorsed moved through the Army's documentation system and arrived in early 1946 in the files of the Armored Force Board at Fort Knox, Kentucky, which was in the process of reviewing the lessons of the European campaign and determining what those lessons implied for the development of post-war armored doctrine and equipment. The board included among its members 2 officers who had served in the European theater and who had read Parrish's reports at the time of their circulation. One of them had written a marginal note on the February 2nd after-action report when he first read it, 6 words in pencil. "This is what close support requires." He still had the note in his files when the board convened. The board's recommendations, issued in 1947, included a requirement for armored vehicles capable of providing direct fire support to infantry at close range against fortified positions, using a combination of direct fire and high-angle indirect fire weapons. The requirement did not reference the Frankenstein Sherman by name. It did not reference Tanner or Whitmore or the Belgian farmyard or the night with the cutting torches. It was written in the language of institutional requirement, translated from the language of operational experience through the process by which institutions absorb individual insight and reproduce it without attribution. The requirement eventually led to the development of the M4A3E8 with the 76mm gun, and later to the M60 series with close support configurations, and eventually to the development of the M1 Abrams supplementary armament philosophy. Not a straight line, not a direct inheritance. The institutional memory of armored development is not that clean, not that traceable. But the argument that infantry assault against fortified positions requires fire support that covers multiple range bands simultaneously, that a single weapon cannot address the gap between artillery range and demolition team distance, that the solution requires layered suppression rather than a single point of fire, that argument reappears in the doctrine consistently enough that its presence cannot be coincidental. Whitmore never knew this. He was not consulted by the Armored Force Board. He was not contacted by the officers who wrote the post-war requirement. He had been discharged from the Army in September of 1945 and had returned to Pittsburgh and rejoined the Ironworkers Union and gone back to structural steel work on the buildings that post-war prosperity was putting up across western Pennsylvania. He was good at it. He was always good at it. He read metal the way he had always read it, with the hands and eyes of a man who had spent his life understanding what material could do when forced into shapes it had not been built for. In 1979, a military historian named Dr. James Harlow was conducting interviews for a study of field improvisation in the European theater of World War II. He was working from after-action report references and unit histories, and the specific trail of documentation that follows unconventional operations through official channels, without fully capturing what the operations required from the men who conducted them. He found a reference to the Frankenstein Sherman in a footnote in a divisional history published by the 2nd Armored Division Association in 1961. The footnote described the vehicle in 3 sentences and cited Parrish's after-action report as its source. Harlow pulled the report from the National Archives and read it. Then he read the Ordnance Department's response. Then he read the divisional commander's endorsement. Then he went looking for anyone who had been there. Whitmore had died in 1971. He had worked structural steel until 1968 and had retired to a house outside Pittsburgh, where he had kept, according to his daughter, a box of photographs and documents from the war that he looked at occasionally and did not discuss. The box had been donated to the 2nd Armored Division Association after his death. It contained, among other things, the original 14 pages of his range band analysis. The handwriting was the same in 1945 and in the photographs of documents from 1979. Compact, precise, the writing of a man who put things on paper to be read rather than to be admired. Harlow interviewed Vasquez in San Antonio in the spring of 1979. Vasquez was 62 years old and had run an automotive body shop since 1947 and was, by his own description, a man who had found civilian life satisfying and the war interesting to remember but not to dwell on. He told Harlow about the night in the farmyard. He told him about the welds, that they were the best welds he had ever made, and that he had made a great many welds in the years since and had not surpassed them. He said that he had never been sure whether this was because the night itself had made him work at a level he could not routinely sustain, or because the stakes had focused him in a way that routine work did not, or because Whitmore's design had been good enough that the welding was not carrying stress it had not been designed for. He said that Whitmore had understood what he was building in a way that made the building of it feel necessary, not dramatic, not heroic. Necessary, as in, the situation requires this, the materials are available, the question of whether it is authorized is a different question than the question of whether it is needed, and the question of whether it is needed has an answer that the casualty lists provide. Harlow asked Vasquez what he thought the Frankenstein Sherman had proven. Vasquez thought about this for a moment. He was a man who had worked with his hands for 60 years and who considered the relationship between thinking and doing to be a relationship in which doing had a higher evidentiary value than thinking. He said that it had proven what Whitmore always said it would prove, that the gap between the artillery and the infantry was a gap that existing weapons could not fill, and that a vehicle with 3 weapons at 3 ranges could fill it, and that filling it kept the engineers alive long enough to blow the obstacles, and keeping the engineers alive long enough to blow the obstacles let the tanks through, and letting the tanks through meant the infantry went deeper and fewer men died in the frozen ground in front of the concrete. He said that all of that had happened on February 2nd, 1945, exactly as Whitmore said it would. He said that Whitmore had been a man who read metal the way some men read books, who understood what it would do and what it would not do, and where the difference lived. He said that the Frankenstein Sherman was ugly in the way that solutions to real problems are usually ugly, not because the work was bad, but because the problem was irregular and the solution had to match the problem's shape rather than conform to the shape that would have been easier to build. He said he had never made better welds. Harlow thanked him and drove away and spent the evening in his hotel room reading Whitmore's 14 pages of range band analysis and thinking about the gap between what institutions design and what situations require, and the men who fill that gap with cutting torches and aluminum bar stock and the specific knowledge that comes from a lifetime of understanding what metal will do when you ask it for something it was not designed for. The Frankenstein Sherman burned on March 19, 1945, outside a German town whose name Tanner could not remember clearly 50 years later when a researcher asked him. He remembered the sound of the 88mm round striking the hull. He remembered the heat. He remembered climbing out through the driver's hatch and moving away from the vehicle without looking back, because there was no value in looking back at something that was finished. He remembered Whitmore standing outside the fire for a while, not moving, not speaking, just looking at it. Then Whitmore had gone to find a telephone and called the maintenance depot and requested a replacement vehicle. He was, to the end, a maintenance sergeant. The vehicle was gone. There were other vehicles that needed attention. The work continued. The Siegfried Line that the Frankenstein Sherman helped breach on February 2, 1945, was the same line that Hitler had described as impenetrable, that German engineers had spent years building, and German defenders had spent months defending at the cost of lives that the Eastern and Western fronts consumed with equal impartiality. By the spring of 1945, the line had been breached in multiple sectors, and Allied forces were moving into Germany's industrial heartland. The war in Europe ended on May 8, 1945. The Dragon's Teeth that Brewer's engineers demolished on the left flank of the 2nd Armored Division's sector on February 2, 1945, are still there. Not all of them. The 4 that were blown are gaps in a line that otherwise runs intact through the Belgian and German countryside, concrete pyramids that have been standing since 1938 and that tourists photograph now because they are picturesque and because the war that required them is far enough away to be scenery. The gap that Brewer made is a gap in the scenery, a space where the pyramids used to be, where 11 engineers moved through under fire with demolition charges and created the 4 meters of cleared ground that the Sherman Company needed to enter Germany. The thing that kept those 11 engineers alive long enough to make the gap is not marked anywhere at the site. It burned on March 19th, 60 miles to the east, and left nothing that a museum would have wanted. What it left was the gap, and the 11 men who walked through it, and the argument in 14 pages of a notebook that a maintenance sergeant from Pittsburgh wrote in a Belgian farmyard in October of 1944 because the casualty lists had become intolerable and the cutting torch was available, and the metal, as always, was willing to become whatever the situation required. Clyde Whitmore read metal the way some men read the future, not with certainty, with the practiced eye of a man who understood the material's limits well enough to find the space just beyond them where it would still hold. He found that space in a Sherman hull and a Greyhound turret ring and a mortar tube and 45 minutes with a cutting torch on a cold Belgian night. He found it in the gap between the artillery and the infantry, where the concrete was waiting and the engineers needed time, and a machine that did not exist in any catalog was the only thing that could give it to them. They called it Frankenstein. It answered to the name.